being recorded here. If you're wanted, man, you're in trouble here. Okay, if I guys can have your attention, I know you just listened to Chad's boring presentation a second ago. That's the problem when you. I was teaching until 9:30 last night. I do apprenticeship 6:30 to 9:30 online, and it was about models. So interesting. Get hyped up. Okay, what I would like you guys to do, if you don't mind, is Joe is an expert in the Risers-Hallberg line diagram, and he will probably draw the line diagram and talk about the difference. And we're going to be doing risers, and you like risers, so how you guys do risers at Hallberg and so forth. Just before Joe starts, I want to remind you guys, next week we will be throwing panels in the walls, and we will be doing views for them, and we'll be building the riser. So that's kind of the plan. The plan for the riser is next week. So that will prep you into how we're going to have the risers. So, Joe, we're going to have a 600 amp panel, 125 amp receptacle panel, 225 amp lighting panel. We have a transformer, and we're going to have a termination box, basically. And you're familiar with the location of that equipment. So I'll let you guys go with Joe here.
I'll just kind of go over the difference, I guess, between a one line and a riser. Again, it's the same information. It's just showing it two different ways. And there are, I guess, it's good for everybody to kind of understand that there's two ways of showing things, especially because there are engineers out there that still use one-line diagrams, and whether you're on the engineering side and you're looking at drawings from a existing building and trying to understand what they did, if you're adding on to that building, or if you're on the contractor side and you're bidding a one-line diagram, you're gonna, like I said, it's the same information, but it's a different way of showing it. So I guess a one-line diagram is more done with showing everything, including breakers and fuses, kind of on one sheet, while a riser is kind of showing things from almost, I guess, almost as if you're standing in front of it, looking at a wall filled with panels. Obviously, panels aren't always in the same room, as you know, it doesn't always work out with larger buildings that the panels are all in the same room. But I think in this one, we kind of are lucky that everything is in the same room. But risers are done more with schedules. So instead of showing a panel on your riser diagram and having the breaker that feeds that panel shown on that riser diagram, it might have a schedule that goes along with that riser diagram that you refer to. Hallberg likes to use risers, and I've always used risers, and I have had very minimal experience with one lines. So I'm not even going to try and draw everything in a one-line diagram. But so like I said, I was kind of taught with risers. It's always kind of made sense for me because I can take like a panel board summary schedule. I guess I shouldn't say me, but like a contractor, when he's bidding a project that I put together, he can take my panel board summary schedule, which he can, you know, make a copy of it in 8.5 by 11 form, and he can send it to Graybar, and Graybar will look at the 10 panels that I have listed in my schedule, and he'll get a bid from Square D, and then that's kind of, it simplifies things rather than sending out, you know, a 30 by 42 one-line riser or one-line diagram with everything. You can kind of cut and paste what you want. Because do you have any examples of schedules anywhere, Chad, that we've kind of used in the past?
Panel schedules?
Yeah.
Yeah, we do. They use panel schedules, so they in the last quarter. So you're familiar with the panel schedule, guys, right? So you need to flash one of. I can flash one of the. Older project here. Give me a second. I'll show you.
Well, I guess that was if there's blank ones, but
blank ones.
yeah, you don't have any blank ones. Okay, that's fine. So that's kind of the basic differences one line versus a riser. Trying to think if there's anything else.
We do the risers for short circuit analysis and coordination, all the stuff. I mean the one line diagram. It comes really handy.
You kind of do the one lines, and do we work with SKM?
Yeah, we're gonna
okay, yep.
we're gonna do it this project for the first time.
So that's kind of my exposure to one lines is with SKM power tools for short circuit calcs. You basically build the riser, except you build it in a one line form. So and that's how you get your short circuit calcs. And power tools is just another another tool for you guys to learn to use to I guess another thing to throw on your resume that you have experience with PTW, because that's something that a lot of places out there are looking for experience in. I know I saw an engineering firm just about a month ago that was looking for a guy to pretty much run PTW specifically. So you're gonna open up.
Yeah, I'm just saying. You want to write? You can write here. It's just opening it. I was thinking I would show, but it's in the background. If you I can get you here. Yeah, okay.
So a riser, I'll try and draw just a crude little.
There's a eraser. Yeah.
It's a little bit. I'll make do. So your riser, just kind of a quick crude example here, is going to have, like I said, like a feeder schedule. So this will be feeder 1, which we'll refer to that, and then you'll have, same sheet, maybe a different sheet that and this will say whatever your feeder to your main is. So your 600 amp, your 400 amp feeders, however many sets of parallel 500s, 400s, while a one line will show the exact same thing, except it'll kind of it'll start at the top here, and this bus right here is your, so your transformer is here, and this bus right here is your main panel. So then the breakers that feed from your main panel, so you're going over to here, which this is another panel, so this is H and this is L, and then so this bus right here would be panel H, and then this, I guess, would be another bus that would be panel L, and then you would show the breaker that is in panel H right in this location to feed panel L. So again, I'm not the best drawer, but that's kind of the basic explanation of the differences between the two, where you would list this breaker kind of just in text right next to it for a one line, where here you would have a schedule that would list all the breakers in panel H separately, besides having feeders also in a separate schedule. So does that kind of make sense? I'm kind of trying to make it as crude and basic as possible. I guess the only main thing is understanding that there's two ways of showing things, two ways of looking at the same information. So you want to touch on anything with one lines, I guess?
Yeah, you know what, I do a medium voltage class. Let me just show you guys a very good I thought,
bring a one line with
yeah.
you. Gotta bring
So this one I'm thinking of, just to show them, and then we start. Okay, come on, Chad, where did I put my my documents? Okay, here, I believe I put them in the training here. And that was our custom training. And we do, no, not this one. So if we could get me media voltage. Okay, we had this. I don't know if we can power this one here. Take a second. This is what, here's what I want to show you guys, that one. This is what one line diagram riser will look like. Oops, where did they go here? There you go. This is what a riser would look like. You want to go or you want to go? Go ahead. So you start with the transmission line. This is major riser. You start with the transmission line coming to the building all the way to the medium voltage transformer. These are the buses. And from the bus, you have relays. These are medium voltage side. The top is medium voltage. You have relays that control motors, multiple motors, and you strip it down into a, I believe this is probably, here's also 4160. So you show all the relays, and you show the overcompression device, which is in this case relays, and you go all the way down to what you guys deal in with, which is circuit breakers and low voltage. So it shows a lot of information. When you guys when you stay the last week of the class, we're going to be doing something very similar to this. This is from SKM. So a riser will basically start from the power coming into the building all the way to the major equipment. You only show equipment, major equipment, like 30 horsepower or more, you show them in, and 100 amp panel or more. You don't show grand circuits. You show major equipment, 30 horsepower or more, and 100 amp or more, you show them in here. So who cares? Here's my, I don't know if it's going to right. Oh, it's right there. I don't know if you guys can see this one. This is the short circuit capability coming in and going back into Excel. So that's why the major reason why we use one line diagram. It gives us short circuit, and out of this calculation, you can get a label that looks like this label here that says warning arc flash hazard. So that's a big deal for when you want to put every panel have to have a label like this. So anyway, without stealing your thunder here.
No, that's kind of what I was looking for.
Yeah, but this is exactly what you're going to be using, mostly using one line diagram for, is short circuit analysis and coordination and so forth. So,
but like I said, there is still engineers out there that put this together as their riser diagram and try to get the power distribution for a building across with this information. I just have always thought that a riser is more contractor friendly for bidding purposes. So
you're absolutely right. You're absolutely right. From a bidding purposes, really great. So this is a one-line diagram. When it comes to analysis, you are dealing with one-line diagrams. Every time you come to analysis, you're dealing with one-line diagram, short circuit coordination, harmonics, you name it. So I'm going to move this one away and let you. There you go. Move you to a different page. Or,
right. Is there any, you guys have any questions, I guess, on this? I don't know that I have too much more information. Yeah. The type of schedules that you guys will probably be using, obviously a panel board schedule for each panel board, a feeder schedule, a mechanical equipment schedule that will list all your mechanical equipment. What else am I missing? Light fixture schedule.
Okay, so this thing
probably don't really have any transformers on this one. I guess that's probably the
schedule they're gonna use. Yeah, I'm trying to show one that we did, Joe, and then you can probably go over that one too. I think winter project, design drawing, Revit. If I can fire that boy. Okay. Electrical backup, electrical central. We just override existing. This is the one that we have done before, and it shows a few of the risers, so give them an idea of how to do that. I know you guys have done one-line diagram with me last time, right? When we showed all the meters. And So this time we're gonna do a riser, which I'll show you a couple of examples of that one when it loads. I know you guys are notoriously famous on your risers, doing a lot of risers.
Yeah, when it was, 15 years ago, when everyone was using one lines, we were one of the only
Yeah,
people
doing
using
risers,
risers, and
yeah.
now it's kind of the opposite. So
Yeah,
everyone's using risers now.
yeah.
I think like say either DLR or done using one line still. Maybe it's DLR.
Mhm.
It's one of the bigger firms downtown. They still use one lines quite a bit.
Yeah. The challenge is sometimes not either or. They use a mix of both.
Yeah, kind of like a hybrid.
Yeah, they use a lot of people. Michelle uses mix of both.
So they,
They use risers for analysis and risers for contractors and one line diagram for analysis. I don't know if I can get into my riser. Okay, so I want to let Joe talk about this one. He probably, Joe, that will make sense. It
Yeah.
looks familiar to you. Okay, this is what you guys are going to be doing with us, basically. So,
so this is kind of, you can see your transformer, your generator out here, kind of showing, as if almost you were standing looking at a cut through the building. So this little line right here, that's everything outside, outdoors, on this side, and the indoors. So you've got your transformer and your generator, your transformer feed coming into probably a connection cabinet there. And then from that going in to your main panel, actually through the transfer switch, and then your receptacle panel and your lighting panel. And these are the feeders. You can see here you've got everything tagged here for feeders. So feeder number 1, feeder number 2, 3, 4, 5, referencing these feeders. So, like I said before, if you're bidding this, it's pretty easy to kind of, this feeder number 1 is tagged. You know exactly that your feeder number 1 is 2 sets of 250s. It's in PVC, Schedule 80, and so that kind of says your feeder, the size of your feeder. You go to your site plan, you figure out the distance, you take off the distance, and you've got your number. So then these panels here are RP, LP, MP. So you're looking at those, you would,
just one mistake here. This should come to the auto transfer.
Okay.
I don't know if it's confusing you.
it is actually.
Yeah, it's good. So you're bringing the power guys from the transformer into the meter cabinet, out into the auto transfer switch. Then you bring a generator power to the auto transfer switch. Then the power goes from here into the main panel, and out of the main panel into these 2 sub panels. And that's what your project is, right? So you have your transformer sitting right here. We have a generator you guys are going to size. That's a gen. Because we are higher than 400 amp, you have to have a termination box. We threw this one on the wall here. So you come out from the generator, from this one in, and from this one out. And then emergency panel is coming directly from here into the auto transfer switch. Can you guys see the picture, how the power is coming into the building? And then, like we said, Joe, then you have to have a feeder scheduler right here that identifies each numbers, what size of each feeder, the size of the conductor, number of conductors, the insulation, as well as the conduit. Does that make sense? What you guys are going to be doing? So it's not really that complicated, this project.
No, it's not.
Yeah.
It's a pretty basic, simple riser. There's probably another sheet that goes along with this that has schedules for each of those panels.
Yeah, thank you.
So you go to RPE.
Then when you
another sheet, there'll be a schedule sheet.
There you go. This is when these are equipment panel schedules. When you come over here, this is all the panel schedule that comes with each one of them. Thanks. There you go. So that's my RP panel. And you guys are going to be doing this one directly from Revit. So these are your panel schedules that will come with it. So here's my RB that goes with the receptacle panel. I think we have an MP, the main panel. We ran a schedule for it too, which sometimes you don't. And we have the LP. So 3 schedules goes with 3 panels, plus the feeder schedule, if that makes sense. Jewel, I mean, is that what basically the whole?
Yep.
So you show what the equipment is. For us guys, because we're doing it with Revit, these schedules will be really nice when you do this. We wait until the last minute until we circuit everything. We run a schedule, and we'll populate these schedules for you auto. So it's really cool. For the schedule for the riser though, so you're not gonna miss with the riser when we do it. For the riser, I want you. Can you guys see when I hover over it? It shows view. Everybody can see that one. That's what you're gonna be doing with me. Um, so this is your view that you're going to be bringing. And then the rest of it is really just annotation. They call it annotation, just draft. I know when you guys did the setup, we were looking at where detail lines and you go draw. So everything here is really draw. It's like CAD, the way we did it. The schedule is also draft. The only thing that's coming directly from CAD are these panels. These panels are physical mechanical panels on the wall, located in the wall. So when we do the schedule, Joe, before we even start with the schedule, you guys go, I'm gonna ask you to go inside your Revit, pick a panel, put that panel on the wall. So you're gonna pick 3 panels. You're gonna pick panel 1, 2, 3, throw them in the wall. Then we're gonna pick a generator outside, pick a transformer outside, and I think we picked also auto transfer switch. We threw it. So just put them in the wall. Then you take a view of them, take a picture basically of them in Revit, a view of them, and we bring these views right into this sheet, and then you start drafting these lines. That's why I call it the poor man's way of doing it in Revit. Because you don't take the full capability of Revit, but it still shows.
You're still showing more than we would in CAD.
Yeah,
you still
that's
have
right.
a live view of those panels, which is
Yeah.
more than we would have in CAD. So even though you're drafting the feeders and they're not
Yeah.
true feeders, it's still way more than we would show in CAD. So.
Now, therein, I want to warn you guys what happened in the past. If you go inside the building and move this panel this way, just slightly to the side, guess what's going to happen to your one-line diagram? You go back to your one-line diagram, and that box is sitting right here by itself. Because that's you're looking at a view. Every time you physically, it's like this panel here. You go move this panel, put it in this wall, it will disappear from your one-line diagram. So be very careful when you put your panels and you take a view of them and put it in the riser to connect them with lines. Make sure if you are to move the panels for whatever reason, you ran out of room, you're going to adjust it. Make sure you go back to your riser and adjust it in the riser. It's not a big deal. You just have to, if that panel moved this way, I just want to get rid of this wire here and bring it this way. So, or wherever, like in this case, it's going to be coming from the top actually. So just be aware that these are views, live views when you put them as a riser. It'll make a lot of sense when we throw them. But what I want to emphasize, like Joe said, with riser, you have to have a schedule that shows all the feeders coming into the riser, into the building and out of the building into the generator and so forth. Any questions, guys? Any comments about that? As long as we have Joe here, do you guys have any question about the load calculation, about the circuiting? We were just talking about circuiting today. Branch circuits, how many circuits you can ask his opinion of how you guys do it. Is not how many lights you throw in one branch circuit, 20 amps, how many receptacle you can throw in 20 amp circuits, or do you have rule of thumb, Joe, for these, or you guys, it depends upon the whole
I usually use
panel?
that little Excel, there's Excel Energy cheat sheet that says that a 3-lamp fluorescent fixture with an electronic ballast is 85 watts and a 2-lamp is 58 watts, and so when I'm circuiting lighting, that's what I usually use. For receptacles, 200. I know you can use 180, but it's kind of a little factor in there.
Okay.
And then obviously if it's feeding something, if it's a receptacle, but you know that water cooler is going to be plugged into it, or a refrigerator, then I usually bump it up, like a refrigerator or a microwave, 1,000 watts. because even though it's a receptacle, you know what's going to be plugged into it. So that's kind of when I'm doing things, it's pretty similar to how you do a residential one. So.
Yeah.
The one thing I will say, the mechanical electrical room for this building, sometimes it comes up, sometimes it doesn't. One of the main things we do when we're laying out mechanical and electrical rooms, especially when they're combined, is we coordinate with like a mechanical engineer. So I need to know the size of his air handling unit. So when I put my panel in, you know, his air handling unit isn't sitting in front of it in my clearance space for 3 feet in front of the panel. On this project, I think we kind of want you to focus on laying out the room, getting the panels, the electrical panels in there. I don't know if we really need you to find out the physical size of the air handling unit. I've never done it with this specific project, but it was told to me one time that the equipment that we gave you, probably because there's transfer switches, things to do with the generator, there's additional equipment that we don't have in our building right now. So if you tried to lay it out with the size of the air handler, the size of the boiler, the panels, the fire protection service, everything, it just wouldn't fit. So that's why we're kind of telling you, focus on getting your panels laid out, tagging your motors so you have a connection for them, but don't worry about laying out your room so it's perfect, so your air handler fits and your boiler fits and everything. Just kind of get everything wired up, get the right size feeders, the right size disconnect, the right size starters that you need. So kind of just a generic comment on that.
Yeah. So this is when you build your riser, guys, with me next week. The first thing you're going to do when you build a riser is go to the mechanical room and drop main panel. This is just a family, main panel, receptacle panel, and LP. And these guys did not do a good job, to tell the truth. This auto transfer switch should have sat right in here. And you drop them, and then you take, so when you drop them all here, side by side, then you take a view of them. You take a view here, which is basically a picture of it. And that's what you guys were looking when you were looking at the one-line diagram. You were looking at a view of this, which means if you come here, Adam, and you move this panel from this wall into here, guess what's going to happen to this view? Now, your riser, that panel will disappear from your riser. Not a big deal. What you need to do to solve it is you need to come in here and make another view right in here and drop that view in the riser sheet. And it's easier done than said, really, when we start doing it. So I just want you to know that's how we do in Revit. These are views. And then outside, what we did too is outside air handling unit. I don't know if they're showing here. Here's where the transformer. They didn't even tag him. Here's the view that I was talking about. They're taking these two views to look at the generator and the transformer, or vice versa. No, the generator transformer. To take this view into E3, which is my riser. Okay, so that's kind of what I wanted to. I don't know, Joe, if you have any other things that for them. It's just that's the riser. So going back to my riser here, and that's basically what we're going to be doing. And you guys are going to do a better job than this. Definitely, I know I can see this easily. That should have gone this way to the auto transfer switch. Any comments, guys? Any questions about the risers? Then what you're going to do with Chad, you're going to take this one and you're going to do it a one-line diagram later on. Here's my transformer. Here's my generator coming in here to an auto transfer switch. That's how you're going to bring it. And out of here, we're going to bring it to the main panel, right? Here's my main panel. And out of the main panel, you're going to bring it to another panel and a third panel. You guys are going to build this system, basically. That's your one-line diagram for the system. Am I missing anything? We have auto transfer switch. We have the main. This will be my main panel. This will be my receptacle panel. This will be my lighting panel. This will be my auto transfer switch, my gen, and my XFR, right? This is your one-line diagram for the system, if you have to draw a one-line diagram. Which you will, because we're going to be using it also as SCAM. So, not hard, not a biggie. Now, the one that we didn't talk about, if you do it this way, this has to be service entrance rated, so it has to actually have a place where you put 2 circuit breakers in it. And so this doesn't have to be made yet. Give me lines only because you're protecting it from the top here. So okay, any comments, guys? Any questions about the risers? Really not a hard thing. So are you guys done with the load calculation and schedule? Yes, no? Okay, for the rest of the day, I can redline the schedule for you and one-line diagram if you guys okay with it. And if you're done tomorrow, we can start the riser. I know it's scheduled for next week. I have no problem walking you through it. I just don't have energy to walk you through it today. That's all. Cool. You guys have a problem with that? Wait at the end of the parking lot. If I don't show up, it's just because it's cold. Thank you, Joe.
So I'll probably be back 2 weeks, I think, to talk fire alarm. I don't know what the exact schedule is, but I know it's a couple of weeks, maybe even a month.
Yeah.